Today we are going to be discussing general loci. In our last class, we discussed the basic loci. In the general loci, we shall also make use of some of the features of the basic loci. General loci. They are determined by the nature of the question or information. For example, a goat tied with a rope on its neck and connected to a ring and fixed between 2 points of a pole would describe an ellipse or an athletic track of field. This is what I am saying. Here is a pole fixed on the ground, and here is the goat. This is the rope tied to the goat. When the goat is moving, the ring will also be moving along the line, depending on the direction the goat is moving. If the goat is moving this way, you discover that in locus, the path that is being traced by the goat with the rope, which is the same distance from this point to the goat, will be moving in this direction. And it can go like this, also this way, down like this, and this. In other words, if a goat is tied here and is to eat or feed within the environment where it is tied, it can only feed from the region described by the path that has been traced. So you see, this information now has enabled us to describe the path, and the path that has been traced is an ellipse or an athletic track. Similarly, if the goat is tied to a point, it will describe a circle. This is exactly what I'm talking about. Here is a fixed point, and here is the rope that is tied on the goat. And the goat can actually move round, tracing this round the fixed point, and it will describe a circle. In other words, the goat can feed on grasses or whatever it's feeding on within this region, and it cannot feed on anything outside the described path. Anything you feed outside here, even at this point, the goat cannot eat it, because the extent of this rope will not allow it to go further than this path that has been described. So that is it. This now, with the description, with the information, we now see that the goat will describe a circle. Example number 1. Find the equation of the locus of a point P, S, Y, which is equidistant from Q, the origin 0, 0, and R, 2, 1. Solution. Here is the diagram describing the information given to us. The point Q is the origin, 0, 0. R is the point 2, 1. P is the variable point, S, Y. And what they are saying is that we are to find the equation of the locus of a point P, which is equidistant from Q and R. So from here to here, and from here to here, they are equal. That's exactly what they are saying. So how do we find the distance from Q to P and from P to R? You recall your distance formula. So we now say, using distance formula, we have here that our QP squared will be equal to your S minus 0 squared plus your Y minus 0 squared. This will give you S squared plus Y squared. Then you also consider your PR squared using the distance formula, and that is S minus 2 squared plus Y minus 1 also squared. Now we simplify this to give you S squared minus 4S and then plus 4, I am expanding s minus 2 squared, plus, I will expand this one, y is squared, y times minus 1 is minus y, minus 1 times y is minus y, so minus y is minus 2y. Then minus 1 squared is plus 1. We can now simplify this if possible. Then we have here s squared plus y squared minus 4s minus 2y, and then this is plus 5. Now, note that your QP squared and P arrow squared, they are equal because QP is equal to P arrow. Therefore, our s squared plus y squared minus 4s minus 2y plus 5 is equal to s squared plus y squared. Now, collecting like terms, if s squared goes to the left hand side, becomes minus s squared, so this and this will cancel. So let us write it down. We have our s squared minus s squared plus y squared minus y squared minus 4s minus 2y, and then plus 5, everything is equal to 0. So this is gone, this is 0, so we have minus 4s minus 2y plus 5 is equal to 0. Better still, we write it as 4s plus 2y minus 5 equal to 0. This is the correct answer. We multiply through by minus to change the coefficient of s to positive values. It's a better way of writing it. We can also write the answer as 2y plus 4s minus 5 equal to 0. Here we can write it as 2y plus 4s equal to 5. But these variations are okay for us to understand. Take note of that, and that gives us the equation of the locus. Example number 2. Determine the locus of a point inside a square PQRS, which is equidistant from PQ and QR. Option A, the diagonal PR. Option B, the diagonal QS. Option C, side SR. Option D, the perpendicular bisector of PQ. Solution. Here we have the diagram describing the information. A square PQRS. And we are to determine the locus of a point inside this square PQRS, which is equidistant from PQ and QR. This is the line PQ and this is the line QR. Now, in this case, the locus of points equidistant from the line PQ and QR will be the bisector of the angle formed by the line PQ and QR. So we bisect this angle here, which is 90 degrees now. We bisect this angle, and you know how to bisect an angle. You put your point here, you make an arc, and then of course from this point here you can also make an arc, and from here you put your compass, and then you also make an arc. Then at the end you can join the line. So we have this now. We join this, passing through the intersection of the arcs that you have just made. Wash it. Okay, it goes like this. Good. Now you discover that we have bisected this angle 90 degrees, and the line from Q to S is actually the diagonal of the square PQROS. So the answer to this is option B, the diagonal QS. So the answer is the diagonal QS, which is option B. The locus, therefore, the locus is the bisector of the angle that is formed by the intersection of the line PQ and QR. This is the diagonal QS. Example number 3. The locus of a point which is 5 centimeters from the line LM is a dash. A pair of lines on opposite sides of LM and parallel to each distance 5 centimeters from LM. B, line parallel to LM and 5 centimeters from LM. C, pair of parallel lines on one side of LM and parallel to LM. D, line distance 10 centimeters from LM and parallel to LM. Solution. Now we describe what the information that will be given to us diagrammatically. Here is the line LM, and we are looking for the locus of point which is 5 centimeters from this line. Now from here to this line is 5 centimeters, and so a line is drawn along this point. Similarly, below the line LM we have 5 centimeters, and then the line is drawn along this place. Since their distances are the same, then these lines are going to be parallel. This line and this line will be parallel to the line LM. So the answer to this question is option A, which says pair of lines on opposite sides of the line LM and parallel to it, each distance 5 centimeters from LM. So this is what we have described, and so the answer here is option A. And option A is the one I have just read out now. Pair of lines on opposite sides of LM and parallel to it, each distance 5 centimeters from LM. You can now see that we have used the features of what we described in one of the basic loci.